This is the first time of you in this lecture. So, what we're going to do today is determinants and matrices revision. Now, if you have any doubts, please stop me. Okay. Yeah. Chalo. So basically, determinant and matrices. Sorry. Yeah. Determinant and matrices, good evening, are we divided into two parts, not one shot, you can say two shots. First part, we'll be doing the theory part because determinant and matrices both combined are a very big chapter. So today's lecture will be completing the theory part of whatever it is by taking some examples, of course. And after that, in the next class, which is tomorrow, we'll be doing the PYQs. PYQs means this year's only, or sorry, the previous year, January 2023 PYQs will be discussing, and April 2023 as well. So let's get started today. What we are going to do. So it's determinant and matrice. Finding the determinant of order 3. I mean, we don't have to discuss all the basics. Okay, what is a determinant? What is a matrix? I think we can start with here. So determinant of order 3. So let's take for an example. I have a determinant 1, 2, 3, 4, 5, 6, 7, 8, 9. And I want to find its value. So how do we find it? We expanded up along the first row. So we first write 1, 2, and 3, but with alternate plus minus sign. So 1 minus 2 plus 3. After that, to write the cofactors. So if I want to write the cofactors of 1, I'll delete the first row and the first column. So what I'm left with? I am left with 5, 6, 8, and 9. Similarly, for 2, I'll be left with 4, 6, 7, and 9. And for 3, I'll be left with 4, 5, 7, and 8. Now, these are the second order determinants. I hope you know how to calculate it. So, it will be 1. We just cross multiply, correct? So, 9 5s are 45 minus 48 minus 2 times 36 minus this is 7, right? 42 plus 3 times 32 minus 35. So I'll get minus 3 plus 12 plus 9. So this is comes to 0. That means what I'm trying to say is a determinant will always have some value. Any value it can have throughout the all real numbers or not also real numbers. We can also get imaginary numbers. But I hope it is clear how to calculate 3 by 3 determinant. Let's move on to the next, which is area of a triangle. This is basically application of determinants which you may have studied in straight line also. So what is area of triangle? If the triangle has 3 vertices, A, B, and C, with coordinates x1, y1, x2, y2, and x3, y, then we can easily get the area of triangle by using determinants by this formula. What does it say? Area of triangle equals to half into determinant of. Write the coordinates x1, y1, x2, y2, x3, y3, and in the last we'll have 1, 1, and 1 as I have highlighted. Correct? Ruchita, are you there? Are you with me? Are you able to understand? Yes or no? Ruchinita. Nice name. Hello. Are you there? Hello. You can write in the chat box, beta. Hello. Is my voice audible? Okay. Chalo. So from this, let me tell you, a determinant's value can come positive or negative or zero also, but the area is always positive. That means you can use modulus here, or you can just consider the positive value. Next, if important point, area is given, use both positive and negative values. Correct? Why? Because area given will always be positive, but the value of determinant can be positive or negative. So let's find the area of this triangle. This is the determinant. How to write? X1, Y1, X2, Y2, X3, Y3, and then 1, 1, and 1. So this will be 1 by 2. If I try to open the determinant, I'll get 1 into. Should I write it direct? Yeah, let's write it direct. 0 minus 3 minus 0 plus 1 into 18 minus 0. So this will be half minus 3 plus 18, 15. That means 7.5 units is the area. Very simple. I am just taking this so that you can know how to calculate the three order determinant. Many of us still have some confusion. That's why. Chalo. So here also this is the second application. Now please, very simple. You just try to imagine if the 3 points are collinear. That means all the 3 points lie on the same line. What does that mean, guys? That means that they do not form a triangle. And if they do not form a triangle, their area will be equal to 0 because there is no triangle. That means if 3 points are collinear, they will not form a triangle. That means the determinant will be equals to 0. So here you can check these are the 3 points. So we have to show that these 3 points are collinear. So let's see A, B plus C, B, C plus A, and C, A plus B. Here I'll get 1, 1, and 1. What is its value, guys? I'll get A into C plus A minus B minus B plus C into B minus C plus 1 into AB plus B square minus AC minus C square. So here A and A will get cancelled. So I'll AC minus AB minus B square plus C square plus AB plus B square minus AC minus C square. If you can see, all of this will get cancelled. That means this will be equals to 0. That means the points are collinear. Chalo, finding minor. Now, minors and cofactors are a very important part because with them we know how to expand determinant in various ways. We just expanded a determinant along row 1. If you heard me carefully on the second slide only, we expanded along row 1. So if we know the minors, what are cofactors, we can easily get or expand the determinant along all the rows or any columns. Let's see what is a minor. Minor with an example is very simple. So the number of minors will be equal to the number of elements. So here we have 4 elements, M11, M12, M21, M2. Right? So what is M11? M11 means delete the first row and the first column. What we are left with? 6 simple, that is the minor M12. First row, second column, 1, M21, 3, M22, 2. Delete the column and the row which is mentioned here, and we get our minor. So this is the definition. Determinant after deleting. Obviously, determinant of 6 will be 6. Only one element. That's why I wrote directly. Right? Finding cofactor. Now, cofactors are just a step forward from minors. How to find minors? Same way, or not same way. We just, you'll understand what I'm trying to say. If the cofactor is denoted by capital Aij, then the cofactor will be equals to -1 raised to the power I plus j. So basically, minor and cofactors absolute value, what is meant by absolute value without sign, will be equal. Just they can be either minus or plus. Cut difference there can be. Okay. So before finding cofactor, obviously we have to find the minors. Now here also there are 4 elements. There will be 4 minors. Correct. So what is M11? Delete first row, first column. Delete first row, second column. Second row, first column, second row, second column. What are cofactors? Just look at the power. This is Ij. So 1 plus 1, 2. -1 raised to the power 2 is +1. So it will be 2. A12. A12 will be -1. A21 will be -6. Why? Because see this. Let me mark it. Yeah. See this sum, guys. If the sum is even, then both of them remains the same. But if the sum is odd, then we have a sign change. Similarly, A22, sum is even, no change. Correct, guys? Chalo. Finding value of determinant using cofactors. This is what I was trying to say. And after knowing the values of cofactors, we can expand a determinant along any row or any column. Hello, Ruchinita, are you still there? Or you are just present and not attending? You can chat, right? Otherwise, I'll get bored. Yes or no, you can say anything. You can give a thumbs up. You can say, explain something. You can ask your doubts. I mean. Hello, Ruchinita. Are you still here? Hello. Ruchinita. Hello. Come on. Okay, no worries. Let's see. Properties of determinants. These are the properties of determinant. Now, we'll go one by one. What does first of them say? If each element of a row or column is 0, that means if one of the row is 0, this can be anything. Then the value of this determinant is 0. If 2 rows or columns are proportional, that means that suppose I have 2, 4, 6 here and 1, 2, 3 here. And suppose let's say 5, 7, 8. Then if you can see, this row and this row are proportional. And is if we multiply this by 2. will get this. Correct? So that's why this is proportional. That means its value will also be equals to 0. This third one we'll study in matrices just now after some 15-20 minutes. This is important. If any two rows or any two columns are interchanged, then the value of the determinant changes in sign. If it was plus, it becomes minus. If it was minus, it becomes plus. Second last. If each element of a row of a determinant is multiplied by a constant k, E, then the value of the new determinant is k times the original value. That means, let's take an example. 1, 2, 3, 4. What is the value? 4 minus 6 minus 2. If I multiply each row with 2, I'll get 2, 4, 6, 8. What is the value? 16 minus 24 minus 8. That means I have to multiply 2 with 2 square to get 8. That is what it is saying. If one of the row is multiplied, 2, 4, 3, 4, 8 minus 12, minus 4. Then I'll get minus 4. After this is a very important property. This property is basically used when we don't have determinant. Don't have determinant means when we have matrix. Exactly, not don't have determinant. That means we don't have the values in the determinant. So if k is any constant and we want to find determinant of k into a, where a is a matrix, then we can take k outside with the power n, where n is the order of the square matrix A. Listen to my words very carefully, guys. I said square matrix because only then I can use determinant. Determinant is only for square matrices. That means the number of rows and number of columns should be equal. Got it? These are some elementary properties. Let's see other two important properties. Now, this basically means is, you can see this, if one row of the determinant or one column of the determinant, you can see here, is expressed as sum of two numbers, then we can split the two columns which only had single elements remains the same, but the column which was addition of two columns got separated. Now, using this property in reverse order is also valid. And the last property, which is the most important, that is, if in any row I used transformation, I hope you know what is meant by transformation, or linear combination with other rows. That means I added KA, KB, and KC to the second row. in P, Q, and R, respectively, the value of the determinant is unchanged. This does not change the value of the determinant. Correct, guys? Now, determinants, all of the things are over. We'll move on to matrices. I know you know equations are remaining, linear equations. We'll do at the end of matrices. So, first, the types of matrices. What are the types of matrices, guys? Here I have written some special matrices which you need to know. Not special, these are general matrices, general type. We also have a special type which we discussed, column matrix. What is meant by column matrix? It only has one row and n number of columns. What is meant by row matrix? It only has one column but m number of rows. That means the column matrix will look like 1, 2, 3, and so on. The row matrix will look like 1, 2, 3, and so on. Square matrix. Here, number of rows equals to number of columns. Diagonal matrix. Diagonal matrix means all the elements except the diagonal elements are 0. That means this is a diagonal matrix. 1, 2, 3, all elements are 0. Scalar matrix. What is a scalar matrix? The diagonal elements are same and rest all 0. Identity matrix. The diagonal elements are all 1 and rest all 0. And zero matrix. Zero matrix means everything is 0. Correct, guys? These are some basic types of matrices. Let's say addition. Basically, we are doing algebra of matrices now. Addition, subtraction, the same thing. The most important thing we have to do is multiplication. And division in matrix is not possible. Excuse me. How to add? I'm waiting so that you can give answer. You want me to solve? Just add the corresponding elements. That means 1 will get added with 12. So we'll get 1 plus 12, 11. 40 plus 7, 47. Minus 6 plus 6, 0. Here we'll get 86, 54, 56, 5, 10, 9. This is my answer. Correct, guys? Now, this is the scalar multiplication. Now, please remember, unlike determinants, where we used to multiply each single row with a scalar. Here, when we multiply it with a scalar, then every element in the matrix will be multiplied with the same scalar. That means if I multiply a matrix A with 3, every element will get multiplied by 3. But this is not the case in determinant. Please remember, in determinant, we can multiply only one row at a time. So here it will be 9, 6, 3. Every element will get multiplied with 3 and 2b. 2b means every element will get multiplied by 2. And 2, 16, 6. Now, if I want to add this, I hope the question is all yours. Correct? Chalo. Simply add it, guys. We saw how to add it. Next, multiplication of matrices. Please remember, in matrices, we always do row by column multiplication. Let's see. First of all, if I want to find A into B, then one thing is the most important, that I will be able to multiply these two matrices only if the column of the first matrix or the order of the column of the first matrix matches the number of rows of the second matrix. As you can see here, the first matrix, the number of columns is 2. In the second matrix, the number of rows is 2. Both matches. That means yes, I can multiply these matrices. And the resultant order will be the remaining, that is 2 cross 3. The resultant will be the remaining. Okay. So how to multiply? As I told you, we do row to column multiplication. Here will be the element of first row, first column. Here, first row, second column. First row, third column. Second row, first column. Second row, second column. Second row, third column. Let's see, first row and first column. I hope you can see it. First row, first column. Let's multiply. 2 into 2 plus 3 into 1. Here, first row, second column. First row, third column. Second row, first column. Sorry, plus. Second row, second column. Second row, third column. That means the matrix which I got is 4 plus 3, 7, 12, 11, 7, 11, 6. This is max. Got it, guys? Sure. Properties of matrix multiplication. Associated law. That means if two matrices, excuse me, 3 matrices are getting multiplied, then we can group any of the 2 matrices. If 3 matrices are getting multiplied, that means we can group any of the 2 matrices. This is the same when we multiply 3 numbers. That is, if I want to multiply 2 into 3 into 5, that means it is as good as first multiplying 2 into 3 and then multiplying 5. That means 3 2s are 6, 5s are 30. Similarly here, first multiply AB or multiply BC. Distributive law. It says that A will go multiply with B and A will go multiply with C. But if it was like this, then A will go multiply with B, but it's push multiplication. With I is an identity matrix. Then I get the matrix itself. It is same as if I multiply any number with 1. I multiply any number with 1. I get the number itself. Correct? Let's see. Transpose of a matrix. Transpose is obtained by interchanging rows and columns. So if here the first row will become the first column, 2, 3, 4, 5, 6, 7. This is the transpose of A. Is denoted by A dash or A transpose. Properties of transpose. Obviously, guys, if I take the transpose 2 times, I will get the matrix itself. Correct? A plus B the whole transpose is basically A transpose plus B transpose. K into A transpose, where K is a constant. Basically, it's K into A transpose. This is important. If A into B the whole transpose, then if I want to distribute transport, then it will be flipped. B transpose into A transpose. Next are some special matrices. Please look at this, guys. Idempotent matrix. What is meant by idempotent matrix? It is when a matrix ka square is a matrix itself. That is A square is equals to A. Nilpotent matrix. That means when we multiply the matrix K times, we get a null matrix where K is some constant or K is the number of times that we multiplied the matrix. And the least value of K is called index. Involuntary matrix. Involuntary matrix when the square of the matrix is the identity matrix. Orthogonal matrix. Orthogonal matrix means when we multiply the matrix with its transpose, we'll get identity matrix. Symmetric matrix. We'll study symmetric matrix in detail. Is when the transpose of the matrix is the matrix itself. Skew symmetric matrix is when the transpose of the matrix is a negative of the matrix. Correct? Next. The special matrices, symmetric and skew symmetric. You will know why we are doing it separately. Chalo. We all know the definition. If A transpose is equals to A, then it's a symmetric matrix. You can see these examples here. A is this, A transpose is this. You will notice one property. The diagonal elements will remain the same. The diagonal elements will remain the same. And these elements, or you can say the diagonal, will act as a mirror. This is the second observation we did. The diagonal elements remain the same, the diagonal acts as a mirror. Skew symmetric matrix. What is meant by skew symmetric matrix? It is a matrix. It is a matrix when A transpose is equals to A minus A. Here, you will notice this is the A transpose, this is minus A. Both are equal. One thing, the diagonal elements will always be 0. The diagonal elements will always be 0. And it will act as a mirror, but with a negative sign. Correct? Here it should be 1. Sorry guys, here it should be 1, right? Chalo. Next, one of the things you notice is that A plus A transpose will always be a symmetric matrix. And A minus A transpose will always be a skew symmetric matrix. A plus A transpose, always a symmetric matrix. A minus A transpose, always a skew symmetric matrix. So that means I can write the matrix A as the sum of symmetric and skew symmetric matrix. Correct? This comes in very handy when we are doing MCQs. Elementary operations. I hope you know all this. First one, interchanging any two rows. If we interchange the rows here, we can interchange the rows, or we can interchange the columns. We can multiply any one row with a number. Suppose I multiplied this column by 2, and we can add or subtract the corresponding elements of 2 rows or 2 columns. Right? Let's say, suppose I write R1 changes to R1 plus R2. Then this matrix, who is changing? R1 is changing. So R2 and R3 remains the same. R1 changes to R1 plus R2. So add the corresponding elements. So we'll get 5, 7, 9. This is my answer. Got it, guys? Adjoint of matrix. Now for adjoint of matrix, we need to know minors and cofactors. So I hope you remember just now in half an hour early we did minors and cofactors. So I hope you remember it. What is adjoint? It's just the transpose of the cofactor matrix. That means if I want to find adjoint of A, I just have to take transpose of the cofactor matrix. Let's take an example. For 2 cross 2, guys, please remember 2 cross 2. I have a trick, or you can say shortcut, to get adjoint of A. Interchange these diagonals. The principal diagonal. Interchange the principal diagonal. And the other two diagonals will be changing in sign. That means this will become -5 and this will become -1. Correct? I hope you got it. This is valid only for 2 cross 2. Now, important properties or theorems you can say, where all of these are very important. Adjoint of A is equals to A into adjoint of A, and they both are equal to determinant of A times identity matrix. Determinant of adjoint of A is basically determinant of A to the power n-1, where n is the order. Obviously, guys, we are talking about determinant. That means the matrix has to be a square matrix. See, this third one looks like the transpose one property. Adjoint of AB is adjoint of B into adjoint of A. Adjoint of A transpose is basically adjoint of A the whole transpose. Adjoint of A is determinant of A raised to the power n-2 times the matrix A itself. And if I say determinant of adjoint of A is determinant of A raised to the power n-1 the whole square. Correct? Invertible matrices. The two matrices are said to be inverse of each other if their product gives identity matrix. That means I can say B is A inverse or A is B inverse. What is the formula for inverse? It is 1 upon determinant of A into adjoint of A. I hope you remember this formula. This formula is very useful, guys. Very useful. Here basically I have derived it, but only for the purpose that you understood. Next one. Find A inverse. What was A inverse? It was 1 upon determinant of A into adjoint of A. What is determinant of A, guys? It is 4 minus 6, which is -2. What is adjoint of A? I hope you remember. Adjoint of A, interchange the principal diagonals and sign change others. So A inverse will be 1 upon determinant of A into adjoint of A. This is very, very important. You can expect 99% of chance one question will be asked from this. Because from past many years, continuously they're asking one question on this. Consistent and inconsistent system. Let's say these are a system of linear equations, which are 3 equations in 3 variables, x, y, and z. Then, if the solution exists, then the system is consistent. If the solution does not exist, then the system is inconsistent. Now let's divide it further. This system of linear equation can be expressed in matrix form as A into X equals to B, where A is this matrix, X is the variable matrix, and B is the constant matrix. The coefficient matrix you can see A1, B1, C1, A2, B2, C2, A3, B3, C3. Next, this is what we do in system of equations. There can be two cases where matrix A determinant not equals to 0, determinant equals to 0. If determinant is equals non-equal to 0, then it is a non-singular matrix. That means there's a unique solution. There is a solution. That means it is consistent. And if it's a singular matrix, which means determinant of A is equals to 0, then it is further divided into two cases. Adjoint of A into B not equals to 0, and adjoint of A into B equals to 0. If this is not equals to 0, then we get no solution. No solution means the system is inconsistent. If this is equal to 0, we get infinite solutions. One solution or infinite solution, doesn't matter. The system is consistent. Got it, guys? Let's see whether it is consistent or inconsistent. What is the matrix A? A matrix is the coefficient matrix. We have to check determinant of A. Determinant of A, 1, 2, 2, 3, which comes to 3 minus 4, which is minus 1, which is not equals to 0. And if determinant is not equals to 0, then there is only one branch, that is consistent solution. So consistency is there. Correct, guys? So this was all from my side, guys. Thank you all for joining. And we'll see you tomorrow in the next lecture. This is all the theory part that we covered. In the next lecture, we'll be doing MCQs of JEE Main 2023. So till then, guys, bye-bye everyone. Take care.